Thank you. Yeah, so I will continue on the theme of acoustic research that we do in Ecophon. Ola just mentioned that I did my PhD as industrial PhD for Ecophon and in collaboration with Lund University. And as you can understand, Erling was my supervisor, actually together with Ola as well. So for this presentation, I will show you some of the results from that research. By this presentation, the effect of absorbers and diffusers in ordinary public rooms. So to put it in the context of the full PhD program, it was entitled Acoustic Design with Regard to Human Perception. So the idea with this research study was to look into both the objective and subjective aspects of the room acoustics, specifically in what we call ordinary public rooms. So these are typically a classroom or an office environment. So an environment where we work or study. We listen to information from a teacher or maybe from a colleague having a presentation. We do interpretations of what we hear. There could be speeches of more monologue type or also dialogues. And we perform different cognitive tasks. And as you all know here, all these activities are affected by the room acoustics. So this was the type of focus of rooms that we were working on in this study. So when it comes to the more objective aspects, of course, we looked at the type of treatment that we use and how that affected different room acoustic parameters. Then how we changed with using different type of acoustic treatments and look into, okay, how does that affect different room acoustic parameters? Doing that in order to create good room acoustics. And that's when it comes into the second part of that research. So the human perception part, because it's always the people that will define what is the good room acoustics. For this presentation, I will actually focus on the more objective aspects, so the acoustic design part, and just briefly look into the human perception aspects. So, for the acoustic design part, in this case we built up a classroom, so a mock-up of a classroom in that lab that Ola showed. And then we did different room acoustic measurements. Typically for these rooms, we designed them based on the reverberation time, so we measured that. However, we have seen also that sometimes we can have the same reverberation time in two rooms, but still experience them differently. And what we have seen in those cases is that there's a difference in the early reflections. So for that reason, we also measured speech clarity. Then we also wanted to have an understanding of how the room contributed to the energy in the room, so we measure also sound strength. So we started with an empty room, and to that we added an absorbent ceiling. So here you can see the three graphs for these three different room acoustic parameters. We have to the left reverberation time, we have speech clarity in the middle, and sound strength to the right. And as you can see, the absorbent ceiling, which is demonstrated with the orange curve, it affected all the room acoustic parameters that we measured here. We'll not go into detail on that. To this, we added furniture, since we often have furniture in these rooms, or in all rooms, but in this case, we furnished it as a typical classroom. Then we got these results, so what you can see with the black curve. If we look on reverberation time and speech clarity, we can see that we get a large effect, especially in the mid-frequencies, which was mainly due to the scattering. But this furniture also has some absorption properties, and we can also see that we get a small effect on sound strength. Okay, so we use this as the basic configuration. So an absorbent ceiling and furniture. It looks like this for this room. And this is what we call basic configuration. So in addition to that basic configuration, we added absorbers and diffusers. So we worked with a mix of those type of treatments. And in this case, I will show you the results of 4 different concepts. So one was when we added more absorption to the walls, looks like this. We added the diffusers to the walls in 2 different ways. We call it vertically oriented diffusers. In this case, we think about vertical in the sense that majority of the sound waves that are reflected on these elements are reflected vertically. Then we had horizontally oriented diffusers, which look like that, which then reflect the majority of the sound in the horizontal plane. A mix of this was also to put diffusers in the ceiling, so just above the area where we could imagine that a teacher would stand in this traditional classroom. And there's also absorbers on the walls in this configuration. So this means, together with the basic configuration, we'll show you the results for 5 different configurations in total. So we have all the results here, but we'll not go into detail of everything, but just showing you the main differences. If we start looking at reverberation time, we can see that, okay, all these adjustments had an effect on the reverberation time. What's quite interesting to look into is the difference depending on how we oriented the diffusers. So, which you can see in the green and the blue curve, where we see that we get a much larger effect when we had the diffusers oriented vertically. If we look at speech clarity, we can see the same tendencies. Larger effect when we use the vertical diffusers. But then we actually get the highest effect on speech clarity when we added the diffusers to the ceiling, and we also had absorbers on the walls. And actually, these are average values. And if we look into the details of the different positions that we measured, we could see that it was actually, the largest difference was seen for the positions in the rear part of the room, meaning that by installing these diffusers in the ceiling, we could achieve a more uniform acoustics. If we then look at the sound strength parameters, we can see that for the configurations when we use the diffusers in this room, we could actually keep the sound energy in the room, while if we really want to decrease the energy, we should just add more absorption. So what this tells us altogether is the fact that, okay, we can actually, by the use of diffusers, also in this type of rooms, we could actually adjust parameters as reverberation time and speech clarity while keeping the energy in the room. If we are about to summarize this, we could say, okay, an absorbent ceiling affected all the measured parameters, and the effect of furniture must be considered if we think about acoustic design in these rooms. However, the acoustic can be fine-tuned and individually adjusted to some extent with additional diffusers and/or absorbers, depending on the need. If we have the case where we would actually like to have a more uniform acoustics or direct the sound to a particular area, then diffusers could be a solution also for this type of rooms. It's also a solution when we want to keep the energy in the room. However, if the case is that we really want to decrease the sound energy, then adding more absorption should be the solution. If we want to use the diffusers, we do have to consider these directional properties. So we looked into how could we do that. So there is a model that Ola also mentioned that Erling has developed, a statistical energy analysis model, which you can read the publications, that has been designed particularly for this type of rooms where we have an absorbent ceiling and where we have 2 different types of sound fields. In this model, it's taken into consideration that it could be both a grazing field and a more diffuse sound field, and the fact that by introducing equivalent scattering absorption area as a parameter, that is taken into account how, for example, furniture will affect the sound field, going from this more grazing sound field to the more diffuse sound field. So the model itself was not part of this PhD, but what I did was to look into whether this parameter could be used to quantify the effect of the diffusers, and especially taking into account these different directivities. So we tested different setups of patterns of diffusers, like putting them separated all together with these different directivities and also different amount of diffusers. So, and what we could see was that actually, okay, this parameter could reflect over these differences. So it seems to be sensitive for the different type of configurations. However, that was for the evaluation in a real room. In a design phase, we need to be able to quantify it in advance. So we tested it also in a laboratory environment, a reverberation room, and compared, could we achieve the same values for this parameter for the real room as in a laboratory setup? And actually we could see that we can have actually similar values if we quantify it in a lab. So telling us that this way could be using this model could be a way to actually quantify this type of elements if you want to use them in a room with an absorbent ceiling. Okay. So we'll just have a short look at also the human perception part. So what we did in this study, using the same classroom as you've seen before, we put a speaker in a position where typically the teacher would stand, and then we recorded sound in different positions. There was some different questionnaires to a listening panel where they were about to look into, answer about what they thought about the differences between different positions in different configurations. They were asked to choose from different words, different type of attributes of what they heard, etc. And to just show like the principles between these different, using the different types of treatments, we could see that. Okay, so you have to the left, it's only an absorbent ceiling. In the middle, adding more absorption, and to the right, when we had diffusers. So how did they experience the differences here? One thing was when it was related to the rating. People found this one as the lowest one, the worst one, out of these three. They found it echoic, however, quite uniformed. When it comes to the solution with having more absorption, that was actually the first one in their ratings. They found the speech to be clear, however, quite non-uniformed. So they said that, okay, it's on average, it's a clear sound in this room, or clear speech that they heard, but it was quite different depending on where you were sitting. So we have three different configurations here. We had the lowest, the first, so this was in the middle. People find the speech quite clear, but this was actually the case where people find it most uniformed. So it tells us that, okay, we need to have a high level of absorption as a starting point, but to actually create a uniform acoustics, meaning everyone should have the same ability to hear properly what is said, we should think about adding diffusers also to this type of rooms. We also looked into whether the responses from people could be related to any of the room acoustic parameters that we measured. And what we saw was actually that the perception was best related to speech clarity in these cases. So, to summarize, okay, there's 2 papers also published related to these studies. Some concluding remarks. Unabsorbent ceiling as the first acoustic action is good baseline. Additional treatment to fine-tune and individually adjust different parameters could be done. If in the case when we want to use diffusers, it actually seems that that could be a way to create a more uniform acoustics also in this type of rooms. The directional properties must be considered, and we have looked into one way of how we can quantify that. When it comes to the subjective experience, relating that to these objective measures, we could see that C50 was best related to the subjective experience, and it thereby seems to be a relevant complement to the reverberation time that is most often used. Looking to what we are doing going forward regarding this research is to continue working on the diffusers in this type of rooms in an extended room configuration setup. So meaning different dimensions of the room and different furnishing and so on. We are also having a study together with Åbo Academy looking into how diffusers could affect also voice support and not only the listener. We have a master thesis ongoing that Erling is supervising, where we look more into how the diffusers relate to or are affected by, depending on what type of ceiling we are using, what's the acoustic properties of that ceiling. And of course we need to look further into perception and acoustic design, both in terms of what are the parameters we should design for, what are the target values we should aim for, and also looking at just noticeable differences for this type of speech when we are looking in this type of rooms. Thank you for your attention.